guys, this is Chen. Welcome to today's lab. Today we are going to learn the Rasch partial credit model, and today we are going to run the Rasch partial credit model by using the ERM package. So the purpose or the objective for this lab is to help you to learn how to run the Rasch partial credit model in R with ERM package. Also, you will learn how to print out like the three primary components for the partial credit model's results. They are item estimates and item fit statistics, person estimates and person statistics, and also how to do related plots such as item characteristics plot, and the right map or the PI map, person item map, whatever it called. So it's gonna be a relatively short lab. Okay, so when we're doing our rating scale lab, rating scale model, you will see like the rating scale model, the same rating scale category structures across the items, and we also need to make sure like the relative distance between each category and the logistic scales are the same across the items. So as I showed you in the previous lab, so when you see the category between like 1 or 2 for item 1 supposed to be the same to item 2 and item 3 and item 4 and all the rest items. And also the threshold can be disordered, right? But we have other requirements, such as, so some categories are not, what if some categories are not observed for certain items, right? So like maybe one individual raters just don't use all the categories, or maybe one items like there is an option which looks even ridiculous, so no students will choose that item. Another thing is the measurement context always might require the multiple scale lengths. So based on these reasons, that's why we have the motivation for using the partial credit model. And here is the equation of the partial credit model. So you can see it almost looks like the same with your rating scale model is in here. So the only difference is in here is they have a little, it has a little I in here, right? This I actually means the specific category within the items. So in the partial credit model, our model not simply regarded all the categories, the distance between these categories are the same across the items. Actually, each items could have different categories location. So in here, this is the main point for the rating scale model, which is in contrast to the rating scale model, partial credit model, sorry. So this is the main point for the partial credit model. In contrast to our rating scale model, the location and the relative distance between the thresholds is estimated separately for each item. So in here, I could be the first category, the second category. So based on the different I's, so the estimation is different. Okay, so let's start it by prepare all of the R packages. So the reader R is for imported data. The ERM is for the package is the main package we are using today for running our partial credit model, and the plot R is for plotted item characteristics curves, and the right map is for the variable map. So let's library it. Okay, so and since we are using like the same data set with the previous lab, so basically it's 12 raters rating 32 students by their academic achievement. So 0 is low achievement, 1 is middle achievement, and 2 is the high achievement, right? let's do this part is the same when we loaded the data. This part is the same with when we loaded data in the previous lab. So we have this data run, and then we can check the data. So note that the Radar 2, see the net Radar 2 never used the category 3. It's always 1 and 2. And for each radars, say you have 3 categories, except Radar 2, right? So these are the same things with the previous lab. And let's summarize that. Since that's the same data set, so it won't be any change. But the thing is, when you check in here, the category is 0, 1, and 2. But in our real data, it's actually 1, 2, 3, right? And then I will explain that. So let's trim the data first to get the response matrix. So in here, we just don't need like the first column, which is student ID. We just need the pure response matrix. So we just get rid of the first column in here, and then we can have our PC data ready. And you can see here, because the 0 actually is the low achievement, is our first category. And also, if you are running the partial credit model in ERM package, so it is highly recommended for you to set the lower risk categories to 0. Actually, this is required from the ERM package. So an easier way to do that, we just simply using this PC data, because the PC data here is the response matrix. We can just use the response matrix -1. So which means each cell of that data will -1. So we got our balanced data set in here. So this data set is pretty much the same with the previous one, but the only difference is each cell automatically -1, right? And I can show you why like the ERM package needs you to trim that. So if we don't trim that, we just run the PC data. Let's see what will happen. Simply, when we run the partial credit model, we just call the PCM function, and let's see if we don't use the balanced data. If we use like the original data set, let's see what will happen here. So you will get something like the following items have no 0 response. So that's Radar 1 to Radar 12. So responses are shifted such that the lowest risk category is 0. Actually, the PC model can run that, but the PC model will shift your data by moving them by 1. So this is why you need a balanced data set for running that. Otherwise, you will have like this warning message. But anything is fine if you don't do that. The ERM package will automatically shift it for you. But like the thing is, sometimes when we coding a data set, they will put like the missing value as 0. So that's where you got your problems. Because if you put missing value at the 0, that means the ERM package actually will regard this as your first item categories. So that's why like you might have other problems. So the best way to do that is always give the data set, give the model a specified data set, which in here is the PC data balanced. Okay, so let's do the PC data balanced for the PCM model. Okay, now you don't have any error message, any warning message. So that means we got our model. In this case, like you will always skip the same model whatever data you placed. But the reason we placed like a balanced data is because I explained, if you have like 0 category, if you noted 0 category, if you noted 0 as a missing value, you might have some kind of errors, right? So you don't want that. You don't want to get that in the real world practice. So that's why you need to avoid that. And then let's do the summary. So once you do the summary, so you should have your estimate for each item categories. Actually, it's not category. You will have estimates for each item thresholds. And then the first one is your item difficulty, which is the beta value. But in here, for each beta value, you can see there's no generalized beta value for each item. For each rater in here, it has like 2 different values. So for rater 1, you have 2 different estimates. That is because the rater 1 used the 3 categories. So 3 categories means 2 thresholds. So these are actually the estimates, the location for that thresholds. And you have your numbers of iterations, numbers of parameters, and also you got your conditional log likelihood. Since the ERM package is using the CML, which is the conditional maximum likelihood. And then we do a right map in here, just simply by using the plot PI map. So this is your right map. And note that so the black one, which is the solid circle here, is the overall item estimate. And these 2 different open circle symbols actually are these thresholds. So the first one is the threshold 1, and the next one is the threshold 2. This is your person's parameters distributions. So basically, you can see like these raters are a little bit higher. Overall, it's like a little bit higher than these persons, which means these raters might hold an relatively more hard standards. Like they are trying to play hard on those persons. And then we plot our ICC. And this ICC is also a little bit different with the previous your rating scale model, because your rating scale model always gives you like a generalized the curve for like the whole item. But in the rating scale model, we are more interested in each subcategories. So for the ERM package, as the default setting, it didn't show up the generalized overall curve for each item, but we still can do that in general. So, and this you can always tell like the 0 in here is this curve, and 2 is this one, and 0 is supposed to be like from high to low, and meanwhile the 2 supposed to be from low to high, which means 0 is the easy category, where the category 2 is the hard category, right? As long like the more you have your ability, this is the latent dimension, which is the ability that we are measure. So like the more you got your abilities, you have your this is the possibility to solve this item. So like the more the chance you got this item solved. So if you do higher, this means like the category 2 is harder category, right? And then we can get the item difficulty, which is the item estimates, by using the thresholds function on the PC model. So then let's check our item estimates. So this is the item estimates. So now this part, if you compare it to your the results for your rating scale model, you will see for the previous lab, like these categories are the same. across the items besides the reader 2. But in here, now it's totally different, and in here it shows you the thresholds. So for the reader 1, he used the 3 categories, and so now we have like the locations for 2 thresholds, and this location basically is the beta is the item difficulty. In this case, it indicates the rater's severity, right? And this value actually is the mean value of these 2, and that's why if this is the threshold 1 only have 1 value, so the mean is itself, right? Makes sense? So this is like the overall generalized the item difficulty or the rater severity for this case. And we can sort them in here, person item. So this is the table we are going to take, and the easy way is when you go in here, you see the models, and easy way is here. You click this button. When you click this button, it will print out your threshold table, and you can check that in here, right? And let's store that threshold table to sort item difficulty. Okay, item, let's see, difficulty. So once you got your item difficulty table, so it's easier for you to sort it. So now you can see like what it is, like the 12, the rater 12, and the threshold 1 is like the lower risk threshold, and you can see like what is the higher risk threshold for the threshold 1, and then you can see who is the most lenient, because like the lower this value means like the lenient, the easier the item or the lenient the rater, right? So the rater 2 is the most lenient rater, and whereas the rater 1 is the hardest one, is the most severe rater, right? From this table, we can see the differences between these raters rating severities, and then we can get the item estimates, standard error estimates. We can just like $se.thresholds, so you will print out the same thing. And this standard error also separated by each threshold. So for rater 1, you have 2 different thresholds right? For rater 2, like for each raters, you have like 2 different thresholds besides the rater 2, because rater 2 only have 1 threshold, because he only used 2 categories. And then let's do the standard error for the, let's just calculate the person locations. Yeah, let's get the person locations. So the person locations, we use the person parameters called on our model. So this is the function and this is model. So let's get that. So the person location estimates is in here, and let's summary that. So you will have all the since we only have like 32, but it's still like it's a long table to see like which one is the highest and which one is the lowest. So the easiest way is you just call on that table. So basically this is what we got, and the CETA table is the table that we are looking for. So we just store that in the person CETA data, and then we can find our person CETA data in here. So we don't need these 2 variables, but we still can, like, if we have like different group, like this is the place you will see different groups for those persons. And now let's just see the first column. The first column is the only column that we need for this class. So if you can sort them, so like you can easily to see in here, because the person parameters actually is the theta, which is the person's ability. So in here we can see the person 20, the ID 24 is the person with the lowest ability, whereas the person 1 is the person with the highest ability, right? Okay, it's not person 1, it's person 1, 10, and 19. They are all the same. These three persons has the highest ability. Yeah, but 24 is the only one has the lowest ability. And then we can check the person, the item fit for both item and person. The fits, and then we can check the fit statistics for both item and person. It's easy to the person location estimates is the objects that we need to call on, and we just use the different functions. One is the item fit function, one is the person fit function, and then we will have our item fit and the person fit ready. Okay, so once you got your person fit ready, so you can simply just check your person fit in here. There is a list in here. You can see the person fit and item fit. So let's check the item fit first. When you click here, so you can see a bunch of values inside one list. This is a list, and then these 4 columns are the information that we need. So you can like simply click that to review all the values. Also, you can, if I want to take out this list, take out this vector, what should I do? So when you click that, you will have this column, and all we need to do is we copy it, and in here, so let's just build in a column called item fit table. And then we can use simply command cbind, and then we just paste, and then we go to the second column that we need. Here is the second column, infit. Paste to here, and then item fit, outfit z in here. The last one is the discrimination, but like in this, here. The last one is the discrimination, but in this case, we don't need that. And we just print out the infit and outfit and their z-score. Okay, so that's it. You can just simply build a table in here. So then you have your item fit table for all the raters. So the first is the outfit, the second is the infit, and these are the z-scores for those infit and outfit. And then you can sort the data to see like rater 7 has like the lowest outfit, and rater 9 has the highest outfit, something like that. And for the person fit, you can do pretty much the same things. When you got your person fit in here, because like you cannot like sort it the list, it's like ordered from 1 to 32. So either way, just like what I did previously, just cbind. Let's do like a person fit table, and then we just use the cbind, and we take out the information that we need. These 4 columns, 1, 2, 3, and 4. So pretty much that's everything that we need for here. We don't need perfect. Okay, so that's pretty much everything that we need, and once you hit that, you can get your person fit table, which is in here, and you can sort it to see who has like the lower risk person fit outfit and who has the high risk outfit. That's pretty much everything. Okay, so that's pretty much everything for today, and you can this is like a little bit exercise you can have. So try to plot the standardized residuals plot. So you should have like the similar code in the previous lab, which is pretty much in the end. Here are the codes that you might to use, and since in here the threshold and since in here the standardized residuals is pretty much safe in the same place, so you can almost like use the same code. So if you cannot plot these standard residuals plot, so just contact me or come into my R help session and I will help you out. So that's pretty much everything for today. Thank you for the listening, and I see you in the next lab. Thank you. Bye bye.